Today we are going to discuss some important concepts related to our third chapter. So our third chapter is pair of linear equations in two variables. So here what you should know basically is what a linear equation in two variables. First of all, we need to know that what is a linear equation in two variables. So here it's given that there are two variables present and it's also a linear equation. What do you mean by linear equation? When the degree of the equation is 1, we call it a linear polynomial or a linear equation. So here we have two variables also. So it can be x comma y. These are the two variables we can use. So let's start with the general form of a linear equation. So in general, we can say that any equation, an equation which can be put in the form of like ax plus by plus c is equal to 0, we can call this a linear equation in two variables. So here a, b and c are real numbers. They are real numbers, and a and b are not both equal, both are not equal to 0. So a and b, a is not equal to 0 and also b is not equal to 0. So what happens when they are 0? Then we will not be having these two variables. Their coefficient will be 0. Then we won't be having a linear equation in two variables. So obviously a and b should not be equal to 0, and also a, b and c are real numbers. So these are the basic about linear equations in two variables. Now when we come to the pair of linear equations in two variables, here pair means what? We will be having two. So here we need two equations, that is two linear equations in two variables. So we generally write the general form or the standard form of pair of linear equations in two variables as a1x plus b1y plus c1 is equal to 0, and also a2x plus b2y plus c2 is equal to 0. So these are the two pair of linear equations. So these are the pair of linear equations in two variables. So here obviously a1, b1 and c1 are real numbers, and also a1 and b1 are not equal to 0. Here a2, b2 and c2 are real numbers, and also a2 and b2 are not equal to 0. Now, so this is our pair of linear equations in two variables. Now, how we will find out the solution for this kind of equations? How we will find out the solution? So to find out the solution, we have two methods. So we have two methods. Now here the first one is graphical method. So what we have to do is we have to draw the graph and find out the solution, and the second method is our algebraic method. So in algebraic method, what we will do, we will use again substitution method. We have substitution method, and also we have elimination method. So these are the two methods we have in algebraic method. So to find out the solution of a pair of linear equations in two variables, we have two methods. So first one is graphical method, and second one is algebraic method. So in algebraic method we have two, that is substitution and elimination methods. So basically in a graphical method, what we will do is we will draw a graph. So suppose this is the graph for the first equation and this is the graph for the second equation. Here we can see both the graph intersect at this point. So this will be our solution for the given pair of linear equations. Okay. So since both are linear equations, obviously the graph will be a straight line. It will not be a curve. Okay. So the graph will be a straight line. So we will have two straight lines. Now, if they intersect at one point, we can say that that's a solution for the given pair of linear equations. Now, based on the solution, we can categorize our pair of linear equations into basic. First two classifications is there. So one is consistent and the next one is inconsistent. So what do we mean by consistent? So consistent means that, or a consistent pair of linear equations means that a pair of linear equations in which two variables which has a solution. So consistent means the simply you can say that the pair of linear equations will have a solution. They have a solution. Now what about inconsistent linear equations which has no solution? So in the case of inconsistent pair of linear equations, they don't have any solution. So no solution. So there is no, if there is no solution, we call them inconsistent, and if they have solution, we call them consistent pair of linear equations. Now the next is dependent. So dependent means that the two equations, they are equivalent and has infinitely many distinct common solutions. That means, so they are equivalent. If they are equivalent, we can call them dependent pair of linear equations. So here, for example, if we have x plus y plus 1 equal to 0, and then we have 2x plus 2y plus 2 is equal to 0. Here we can say both are equivalent. Okay, both are equivalent. So this pair of linear equations, both will have the same solution, or we can say infinitely many distinct solutions. And also the dependent will always be consistent. Why? They are consistent. Why? Dependent pair of linear equations, they are consistent. Even though they have infinitely many solutions, they still have solution. Okay, they have infinitely many solution, still they have solution, so we can categorize them as consistent. So if they have no solution, we can call them inconsistent. Now to find out whether the given pair of linear equations is consistent or inconsistent or dependent, what we can do is we can just analyze their coefficients. So suppose our first equation is a1x plus b1 y plus c1 is equal to 0, and our second equation is a2x plus b2y plus c2 is equal to 0. Then what we can say is that first case will be that when a1 by a2 is not equal to b1 by b2. Okay, so that means they are not equivalent, or we can say here the coefficient of the ratios of the coefficient of x from the both equations is not equal to the coefficients of y, the ratio of the coefficients of y. So this is our first case. So in this case, what happens is that the two graphs, when we draw the graphs, the two graphs of the particular equations, they will intersect. Okay, so in this case they will intersect. When they intersect, what that means? That means they have exactly one solution. They have exactly one solution. So this is our first case. Now moving to the second case, what we will have is we have a1 by a2 is equal to b1 by b2 is equal to c1 by c2. So in this case, all the ratios are equal. The ratio of the coefficients of x is equal to the ratio of the coefficients of y is equal to the ratio of the constants. So here all the ratios are equal. So what we can say that is they are equivalent for one case, and also they are coincident lines. They are coincident lines. Okay, so that means if the first graph is like this, The second graph will be something like this. So both are coincident. Okay, so that means we will have infinitely many solutions. That means here each point in this graph can be a solution. Each of these point can be a solution. So they have infinitely many solutions. Okay, now next, our third case is that where a1 by a2 is equal to b1 by b2. So the ratios of the coefficient of x and y are equal, but they are not equal to the ratio of the coefficient of our constant. So a1 by a2 is equal to b1 by b2 is not equal to c1 by c2. So this means we have two parallel lines. Okay, the graphs are parallel lines. So when there are parallel lines, there will be no solution. Okay, the graphs will never meet each other, so there is no solution. Now, my question is that how many of these cases are consistent and how many of them are inconsistent? So we can say that the first two cases, that is when a1 by a2, these two cases, they are consistent. Okay, they are consistent, but the third case there is no solution, so they are inconsistent. Now which one is our dependent case? Coincident lines is our dependent case. Okay, so these are the three cases we have. Now moving to our one example is given here. So looking into it, let's say Agila, she went to a fair in her village and she wanted to enjoy rides in Janville and play hoopla. It's a game in which we throw a ring on the items kept in a stall, and if the ring covers any object completely, you get it. Okay, that's a game. So you might have seen it in videos or you might have actually played it. So these are the two things that Agila want to play in the fair. So one is a giant wheel and one is our hoopla. Now here it is given that the number of times she played hoopla is half the number of rides she had on giant wheel. So that means suppose we are taking the number of rides she played on hoopla as what we can take x or y. You can take any variable that you like. So I'm taking here y as the number of rides she played on Janville. Sorry, the number of times she played hoopla is y and is half the number of times she played Janville. So y is equal to half x we can write. Half the number of rides she had on Janville is our x. In the number of rides she had on Janville is our x and the number of times she played hoopla is our y. So we can write y is equal to half x. Now next it's given that if each ride costs rupees 3 and a game of hoopla costs rupees 4, how would you find the number of rides she had and how many times she played hoopla, provided she spent rupees 20. So the total amount is given, and also for Janville ride we have rupees 3 as a cost and for hoopla it's rupees 4. So what we can write is our x is what our Janville ride. So we can write 3 into x plus 4 into y. Y is our number of times she played hoopla. So 4 times hoopla will be equal to the total cost. Here total cost is rupees 20. So here we have 3x plus 4y is equal to 20. Now using both these equations we can easily find it. So for example, okay, if I am writing this as 3x plus 4 into, in the place of y I can put half x, 4 into x by 2 or half x is equal to 20. So here this 2 and 4 can get cancelled, so it will become 2x. So 3x plus 2x is equal to 20. 3x plus 2x is equal to 20. That means 5x is equal to 20. That means x is equal to 4. 20 divided by 5 is 4. So the number of times she played or she took the ride in Janville is 4 times. And the number of times she played hoopla will be half of x. That will be 2. She played hoopla 2 times and she took ride in Janville 4 times. So this is how we use the pair of linear equations in two variables to find out various aspects when certain data is given. Okay, so here in this case we were finding out the number of times she played in different rides or different games. So this is how you will do it. So this is a small example. We will look into more examples in our chapter.